Hi, hello. Finally, we're now in the last video lesson for factoring polynomials. Yes, we will still apply factoring in different lessons, but in the meantime, we're now officially done with our concepts from factoring by GCF to grouping to special products, PST, dots, DOTC, SOTC. Then we just had factoring general trinomials where A is 1 and then where A is a real number. And now we're gonna have word problems involving factoring polynomials. We're gonna have two examples for this video, and you may research on more so that you will be able to practice your skills in factoring polynomials, but also in solving word problems involving them. So let's start with our first word problem. So let's start with our first example. So we're gonna have Anya to again guide us with what we're looking for. So let's apply the skills we have learned. So we have Lloyd, and he's planning on fencing the rectangular garden in his retirement house. So the garden has an area of 126 square meters. If the length is 5 meters longer than the width, what should be the dimensions of the rectangular garden? So we're going to apply like the quote unquote questions or guide questions that we use before when you were young in doing word problems. We start with what is asked in the given problem. So using the concepts that we have discussed so far, you should pay attention deeply with what we have to answer and what we have to use. So what is asked is basically the question. So the question is, what should be the dimensions of the rectangular garden? So we're being asked to find the dimensions of the rectangular garden. So that's an important detail that you should pay attention to. So when we say rectangular garden, the word rectangular implies a huge detail for what is given. So yes, we are given with the area of the garden, which is 126 square meters. So let's write that area is equal to 126 meters squared or square meters. At the same time, we have the data or detail that this is an area of the garden, and the garden is a rectangle. Okay, so that's an important detail for us to pay attention to. Next, we also have the terms or the phrase length is 5 meters longer than the width. So, what will we do with this phrase or with this part of the given? Length is 5 meters longer than the width. This is the part wherein we apply representation. So, I would like for you to understand that in some exams or lessons, they ask you to use like a certain variable. But since in this given problem that Lloyd is working on, there is no given variable, you could use your own. So to make this simpler, let's say we have the width and the length of the given garden. So based on this, I can say that the width is dub or W. As the kids say, it's dub, right? That's how they say it now. But let's say we have W as the width. But for the length, should we use letter L? No. Why shouldn't we use letter L? Because there's a given here saying it's 5 meters longer than the width. And since the width is W, the length should be W plus 5. Why plus 5? 5 meters longer than the width. So we're going to use these details in order for us to answer this given word problem. So to continue, now we're asked, what formula can we derive or apply for this word problem? The word is rectangular and the other word is area. Both of those words imply something that we can apply instead of derive. By derive kasi it's based on the problem. Pag apply, the formula already exists. So if it's the area of a rectangle, what formula do we use? Basically, the area of a rectangle is equal to length times width. So this alone will help us a lot in solving this word problem. So to continue, let's now do substitution and solving. So the given formula again is area is equal to length times width. And based on the details that we had earlier, the area is 126. So substitute that. The length is W plus 5 and the width is W. So by distributive property, let's distribute W to the binomial. So we will have W times W, that's W squared, and then W times positive 5, that's plus 5. Now, why do we have to apply the subtraction property of equality? Because we want to put all of the terms in just one side of the equation. It's important to understand that the properties of equality are being maximized in order for us to do factoring later. So, in other contexts, they use the technique which is transposition, but transposition is basically the subtraction property. So, since you want 126 to be together with the other two terms, you subtract 126 to both sides. We do this so that they will all be together in one side. So we'll have W squared plus 5W minus 126, and it's equal to 0. So this is the one that we're going to work on now. With this given, we can now factor it out. So let's have it. Let's have W squared plus 5W minus 126 equal to 0. So this is basically a case of a general trinomial where a is equal to 1 and your middle term is positive but your last term is negative. So the higher number should be positive in this case. So you can try to figure out different factors of negative 126. Have it here, factors and sum. So you can have negative 1 and 126. Well, basically this is equal to 125. You can have negative 2 and 63. This will give you 61. Is this divisible by 3? Yes. So negative 3 and 42. Is it 42? Yep. This will give you 39. So not yet. Is negative 126 divisible by 4? Is it divisible by 4? Nope. Divisible by 5? Nope. Divisible by 6. So how about negative 6 and 21? Nope. It will give you 15. Is it divisible by 7? Yep. So negative 7 and 18. But it will give you 11. So nope. Is it divisible by 8? Nope. Divisible by 9? Yes. So how about negative 9 and what is it? 1, 4. And the sum is 5. So we will use negative 9 and 14. So the factors of this is W minus 9 and W plus 14. And it's equal to 0. Now we equate each factor to 0 and apply the appropriate property of equality to get the value of x. Or in this case, the value of W, the missing variable. So what do you mean by equate? Meaning to say, we're going to separate, so sad. We're going to separate these two factors, just like Moses, separate them in half, and we're going to equate each of them to 0. So why do we equate each factor? So that we can get the two possible values of the missing variable. So now, we're gonna maximize again the use of the properties of equality in order for us to identify the values, possible values of W here. So how do we do that? Since you have W minus 9 is equal to 0, you want to isolate W alone. So you add 9 to both sides. So that W will be left alone, and the answer is positive 9. So W plus 14 is equal to 0. Subtract 14 to both sides so that we can eliminate the positive 14 on the left side of the equation and just leave W alone. So you'll have W is 9 and W is negative 14. Now, which of the two answers should we use? Well, we're gonna use W is equal to 9 because this is negative. This is wrong. Why is this wrong? Because again, it's negative and we're talking about the width of a given garden. Is it possible to have a negative 14 meters for a width of a garden? No. So now, for us to finally answer this word problem, earlier we said the width is W, the length is W plus 5. So since this is W, it's equal to 9, and this one will be 9 plus 5, and it's equal to 14. So we have 9 meters and we have 14 meters. So that should be the measurement for or the dimensions of this rectangular garden. If you multiply 9 and 14, that will give you 126. So therefore, this is our final answer. Now let's have one last example for this for word problems involving factoring. Now let's have Anya, and now she needs your help because Becky is making it hard for her. So Becky is making Anya guess what pages. I missed out a word here. Basically, what consecutive pages of the manga she's reading is her favorite. So the clue is that the product of the two consecutive pages is 156. And what are those two pages? So to continue, again, what is asked? So what are the two pages? So we are looking for the two pages that are consecutive. Two consecutive pages. So that's what we're looking for. Next, what is given in the problem? They are consecutive and that the product is equal to 156. Now, how should we represent that idea of those two consecutive pages in this case? Again, we can use any variable here. You may use x or anything. But for me, I'll use the letter P as our representation. So let's say that the first page is letter P. What do you think should be the second page or the page after the first page? Basically, class, do not make this complicated. Since again, I'm sorry, I forgot to type in the word consecutive, but we're dealing with consecutive pages. Basically, if you open your book, like page 1, after page 1 is page 2. It doesn't jump around like page 10 already, right? So page 1 comes next is page 2. So if first page is P, the second page is P plus 1. We didn't do any magic here. Again, the difference between two pages that are consecutive is always 1. Okay? So with that being said, now we're not using a formula or applying a formula. We are deriving one. So how do we derive a formula? So since we have here the product of the two pages is 156. So basically, using the pattern that we have used earlier, so we should have the first page times the second page. And the answer should be 156. And we have established already that the first page is equal to P. And the second page is P plus 1. And that is equal to 156. So basically, this is how it will look like. We have already done substitution already here. So that's it. So to continue, we have P times P plus 1 is equal to 156. P times P is P squared. P times 1, that's positive P, is equal to 156. And again, our goal is to put all of these terms together. So subtract 156 to both sides, and you will get P squared plus P minus 156 is equal to 0. And this will be our working equation that we will factor out. So again, let's go with our next step. So let's have P squared plus P minus 156 is equal to 0. So we can also do what we did earlier to help us out. So let's identify factors of 156, negative 156, and the sum should be positive 1. Would you look at that? So we can have negative 1 and 156. That will give us 155, way too far. Negative 2 and what's the factor of this? 78? Yep, 78. But it will give us 76. It's also divisible by 3. So negative 3 and positive 52. But that will give us 49. So nope. Is this divisible by 4? Yes, sir. It's divisible by 4. And the answer will be what? 3 times 4, 12, 39? Is it 39? Yep. But will give you 35. So nope. Let's continue. Divisible by 5? Nope. Divisible by 6? Is it divisible by 6? Yes. So negative 6 and 26. But we'll give you a sum of 20. So we're getting there. Is it divisible by 7? Nope. Divisible by 8? Nope. Divisible by 9? Is it divisible by 9? Nope. 10? Nope. 11? Nope. 12? Is it divisible by 12? Well, I guess it's divisible by 12. And if you divide negative 156 by negative 12, the answer is 13. Oh, negative 12 and 13 is equal to 1. And that's what we're looking for. So therefore, the factor should be p minus 12 and p plus 13. And it should be equal to 0. So equate it. We'll get p minus 12 is equal to 0. We'll get p plus 13 is equal to 0. Add 12 to both sides to isolate the p. You'll get p is equal to 12. Subtract 13 to both sides so that you will get p is equal to negative 13. And again, we cannot consider the negative 1 because there's no such thing as a negative 13 page, right? So the first page should be 12. So we have established earlier that the first is p, the second is p plus 1. So therefore, the answer here is 12. And the second page is 12 plus 1, which is 13. So basically, the favorite part of Becky in this given manga that she's reading is page 12 and page 13. So that's it. And I hope with this lesson that we're now done with the entirety of factoring, polynomials, and the word problems. I hope that you are the last Anya instead of the first one. Or maybe you're still in the second part. It's okay. So that's why I prepared this video so that you could look back onto them and enhance your skills. I hope this one helps, and I'll see you soon with our next lesson. Now that we're done with factoring, we're now gonna go with somewhere different, which is basically the world of rational algebraic expressions. And that ends our video lesson for today. I hope you learned something new, or you were able to recall all the things that you need to recall and master all of the skills that you need to master. As always, remember, in case you don't see me or hear me, good morning, good afternoon, good evening, and good night. Peace out. Respect, everybody.